Assalamu alaikum wa rahmatullahi wa barakatuh. Hello, my dear students. My name is Mr. Ahmed Munir, and today, inshallah, we're going to talking about operations on vectors. We must be to know what the meaning of operations. Operation it means adding or plus, minus, times, and divided. This is the operations of numbers as we studied before: plus, minus, times, and divided. And today, inshallah, we're going to talking about adding and subtracting of vectors. The first case we're going to talking about the adding of vectors. Adding of vectors, as we studied before, to adding, for example here, about the vector of A is equal 2 and 3, then vector B equals 3 and 7. So the answer is going to be A plus B, vector A plus vector B is going to be what? Yes, exactly. The first projection and plus first projection, that's meaning 2 plus 3 is going to be 5. And second projection with second projection, that's meaning 3 plus 7 is going to be what? Is going to be 10. This is as we studied before. But today here, what about if there's a person here stay in the point A and moving to the point B? After that, he moving from point B till point C. Moving from B till C. Now, if I ask you, what about the starting point after this distance? We are going to say this is distance, starting point here is A, and ending point is C. So we can say the vector of AB plus vector of BC is going to be starting point is A and ending point is C exactly. So the answer is going to be AC. What about if we denote of letter of vectors AB by vector M and BC we denote with letter N, so by vector N. Now vector M plus vector N is going to be vector M plus vector what? Vector N. So this is the meaning of adding of vectors. What about in this case? What about if the line segment in this one, this is a line segment, this point is A, and this point is B, and this point here is C. This is the first case. What about the same line segment A, this is B, and this point is called C. What about here in this case? This is B, this is A, and this is C. What about if we need to find here AB plus BC for all of these cases? For all of these cases, what we need to find? AB, the vector AB plus vector BC. The answer is going to be what? Looking in the first case, AB from here to here. What is the starting point now? Yes, is A. After that, he needs to start from B to C and B, C. What is the ending point now? Is C. So the answer is going to be here AC, starting point and ending point. The same case here. Looking, AB, AB. What's the starting point here? Yes, it's A. After that, BC. What is the ending point now finally? C. The answer is going to be AC. What about here? AB plus BC. What is the starting point in the beginning? A. What is the ending point? Is C. So the answer is going to be AC. It's also the vector of AC. So I want to say here, in general, if we have here AB, the vector AB plus vector BC. Imagine we are going to cancel B and B, and the answer we are going to put it as it is going to be AC, starting point, and this is going to be the ending point. 4 remarks here. The first remark here, according it's the first figure. This is number 1. ABC. This is a triangle starting from A, so we can say it's AB. This is the first vector, vector AB plus vector BC plus vector CA plus vector CA. So the answer is going to be what? The answer is going to be that we're starting from the point A and the ending point finally is going to, it's also point A. So the answer is going to be 0, and this is 0 vector or vector 0. It's okay. And the second example here in this figure, AB, vector BC, vector CD, vector DE, vector EA. It's also the same. The starting point is A, and we make a round till the point A again. So the vector of AB plus vector BC plus CD plus DE plus vector EA. So final answer is going to be also 0 vector or vector of 0. Okay, case number 3. This is number 1, number 2, number 3, and this is 3, and this is going to be number 4. Okay, case number 3. The vector of AB, starting point here also is AB plus BC. The answer is going to be what? Yeah, it's AC. Again, the vector of AB plus vector of BC is going to be AC. It's not only that. Looking here, we're starting from AB and BC and CD. The starting point vector of AB plus BC plus CD. The answer is going to be what? Yes, exactly. Starting point is A and the ending point is D. But take care. They must be to the same round with a clockwise or anti-clockwise here. All of those is going to be what? Anti-clockwise. Here also is anti-clockwise. This is going to be also with anti-clockwise. So here this one is going to be what? Yeah, it's AD. The vector of AD is the vector of AD. Okay, what about the last one here? The last one here, the same things, starting from A, it's AB, BC, CD, DE, and this is AE. Starting point is A and ending point is A. Starting point is A and ending point is D. AB plus vector of BC plus CD plus DE. All of those, the answer is going to be vector of AE. So let's we need to prove in any quadrilateral ABCD, prove that the vector of AC minus vector BC equal the vector of AD minus vector BD. The first step here, we are going to drawing any quadrilateral. Quadrilateral, this meaning consists of 4 sides. Like this example, it's not important to be a square, rectangle, parallelogram, whatever. Just any quadrilateral, okay? And we'll put here, this is A, B, C, D. Now, this figure consists of 4 sides. What about the direction of this one? What about the direction of from A, B, C, D, and what else? By the way, here we have 2 methods to solve it. The first method by starting with right hand side. This is left hand side and this is right hand side. What about if we're starting from left hand side? What about left hand side? It's AC, the vector of AC minus vector of BC is going to be what? AC, this is the diagonal from A to C. What about if we say this is AB and BC? So the answer is going to be AC. So AC, we can cancel AC. AC is the vector of AC is going to be the vector of AB plus the vector of BC. Let's go to cancel AC and we put its value. The vector of AB plus the vector of BC minus BC. Wow. Now this is the vector of BC and this is also the vector of BC. Now we can cancel both of them together because they are additive inverse. So the answer is going to be, for the part of left hand side, equal the vector of AB. It's okay. What about the right hand side? Right hand side is equal AD, vector of AD minus BD. Okay. Where is BD? BD. I'm going to put AD, the vector of AD first. This is the vector of AD minus BD. We are going to change its places. It's going to be DB, and in the same time we're going to change this sign. This is negative, is going to be what? Positive. In the opposite figure here, AD plus DB plus DB. The starting point is A and the ending point is going to be what? AB. Looking here, this is number 1 and this is number 2. That it means left hand side equal right hand side. It's okay, it's clear now. Okay, what about if we are going to talking about now about another thing? This is referred to, this is drawing is a parallelogram. This is a parallelogram. What's known about the parallelogram? Yeah, each two opposite sides are parallel and equal. Each two opposite sides are parallel and equal, and we must be to know another information about the angles, about diagonals, it's bisect each other, and so on. If we say this is a parallelogram A, B, C, D, and this is AB from this way, and this is AD. We are going to denote this is the vector of M, and this is called vector N. What about this diagonal AC? What about this diagonal? We are going to say the vector AC, the vector of AC is going to be vector M plus vector N. What? How comes? Looking here, as we said here, the properties of parallelogram, each two opposite sides are parallel and equal in length. It means AD is going to be equal with BC, and both of them are going with the same direction. It means now looking here, AB plus BC is going to be AC, is going to be AC, that's right. And BC is equal with the vector of AD, so we are going to BC equal AD. So we can say, and this is now is going to be, it's also vector N. So we can say this vector plus this vector AB, the vector of AB plus vector of AD, the answer is going to be what? Yes, exactly, AC is a vector of AC. Okay, we are going to talking about subtracting of two vectors. In the opposite figure, we are going to say the vector of AC, the vector of AC plus vector of CB. The answer is going to be what? Yes, exactly, the answer is going to be AB. Looking here, AC we are going to do it with letter N plus CB, put it as it. Now we're going to put it as it equal AB. We are going to do it with letter vector M. What about if we need to find here the vector of CB? Yes, exactly. This is we're going to put it as it. It's going to be C, the vector of CB, and this is one is positive. We take it to other side as equation. It's going to be negative. So this is vector M minus vector N. So now if we need to find the vector of CB, the answer is going to be vector M minus vector what? Minus vector N. Okay, let's go to tell you about techniques to find the adding and subtracting by easy way. For example, here this is for adding, and this is subtracting. What about if we need to find AB plus the vector of AB plus vector BC? And here, what about if we need to find the vector of AB minus the vector of AC? Okay. Here in adding, as we said before, in this point, we're going to cancel B and B together. The answer is going to be the vector of AC. Okay, and here we're going to put the second letter. It's also the repeated letter is cancelled, but here we're going to put C first. So the answer is going to be C, the vector of CB, the vector of CB. This is, I think, it's going to be the easy way to find the adding or subtracting if we have two vectors. It's okay. It's clear now. Okay, let's go to have an example to know how we are going to use adding and subtracting in this case. Okay, in this example, this is a parallelogram ABCD. ABCD, this is a parallelogram ABCD. As we studied before, we know the point. He gave me the point of A, point of B, point of C, and we need to find the point of D. We can use it here in any method we can solve it, but now here we are going to use any method we take it in third prep. By the way, this is what I'm talking about. But here we can solve this one by using the vectors. But how? We're going to say if this is a parallelogram, it means AD, the vector of AD is going to be the vector of BC, because we know in the parallelogram, from the properties of parallelogram, each two opposite sides are parallel and equal in length. So now we're going to use the AD and BC. Both of them are equal in length. So equal in length, and by the way, in the same direction. From this side, AD, it means D minus A. D minus A, the vector of D minus vector of A. And this one is going to be also C, the vector of C minus vector of B. He gives me the point of D. No, but we are going to say the point of D is going to be X and Y. So this is X and Y minus B. A, sorry, is going to be 2 and negative 2. C is going to be 2 and 3 minus B, 4 and negative 2. And now, as we studied before, X minus 2, first projection with first projection, and second projection with second projection. X minus 2 and Y minus negative 2 is going to be Y plus 2, because negative and negative is going to be what? Positive. This is this negative here and here also. It's negative here and here. What about the right hand side? 2 minus 4, 2 minus 4, the answer is going to be negative 2. 3 minus negative 2, the answer is going to be what? 5. Now we have two parts. The first projection equal first projection, and second projection equal second projection. First projection here is going to be X minus 2, is going to be negative 2. From this side, negative 2, we take it to the other side to be positive 2. 2 minus 2 equal 0. Y plus 2 equal 5. This is positive 2. We take it to the other side to be negative 2. And it means Y, 5 minus 2 is going to be 3. So the coordinates of point D finally is going to be X equals 0 and Y equal 3. Okay? Thank you for watching my video. Don't forget to support me. Don't forget to share, subscribe, put your comments. Thank you for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.